Okay, so this is going to be Unit 2, Lesson 2, and it's going to be dimensional analysis, um, or how dimensional analysis works. So it's Lesson 2, or it's Unit 2, Lesson 2, dimension analysis, and these are going to be one-step problems. And we'll get more into more complicated ones as we go along. So we're going to use dimensional analysis to solve one-step conversions. And we should probably talk for a second about what dimensional analysis is. So dimensional analysis is a way for us to show, mathematically speaking, that the units that we start with are going to be equal to the units that we end with. And what that means is that whatever value you're actually starting with.
I have one.
Please get it up. That'd be great. Okay. All right. So we're going to be looking at units that we start with and comparing them to units that we end in. And that brings us to something that we refer to as a conversion factor. And the conversion factor is something that makes two measurements equal to one another. So, for example, if I said that I had 1 foot, many of you could probably, from somewhere in the archives of your brain, identify that to be 12 inches. Now, 1 foot and 12 inches aren't two different distances. They're the same distance, but it's a relationship that makes them together the same. So when we go through and do problems with dimensional analysis, we take our starting number and its unit, we put it over 1, and then we take our starting unit in the conversion factor and put it on the bottom. We then take our new unit and put it on the top, and that allows us to mathematically represent how we got from, say, foot to inches in the example. Okay. So I think the best way to talk about how to do this is to do a couple of these. And so we're going to start with something that's common or maybe comfortable, and then show the work, and then we're going to move into things that are a little bit more uncomfortable. So we're looking at a problem. We're talking about eggs and dozens, and it says that we have 48 eggs, and we're supposed to change them into dozens. Now, in order to do that, we need to have our conversion factor, which is basically the relationship. So at this point, we have to figure out how eggs and dozens are equal. Okay. So in this instance, I know from my personal experience that 1 dozen holds 12 eggs. Okay. As a matter of fact, I have 36 eggs in my refrigerator right now because my son, my wife, and I eat 2 eggs each a day for the week, every week. So there's a lot of eggs, right? But in any case, got to get that protein somehow. So what I'm going to do is I'm going to take my given, which in this case is 48 eggs, and put it over 1. And then I'm going to set up my relationship or conversion factor so that I have the unit of eggs on the bottom and the unit of dozens on the top. I'm then going to go back and fill in my values. We know that in the conversion factor, there's 1 dozen, which equals 12 eggs. And then I'm going to go ahead and kind of combine things that I can. So I'm going to multiply straight across because math says that what we do is we multiply straight across, and if it's a fraction, the top, and then multiply straight across the bottom if it's a fraction. So what that really looks like, for those of you that kind of like may have forgot what that looks like, is 48 eggs times dozen over 12 eggs. And so what ends up happening is that the things I can do is I can simplify 48 and 12, and hopefully we know that that equals 4. And I can cancel out the unit of eggs, and so that's left. So that leaves me with a value or an answer of dozen. So 48 eggs is equal to 4 dozen. Okay. Another example that might feel comfortable to us is the relationship between pairs and single number of shoes. In this one, we have 25 pair, and we're trying to figure out how many shoes that actually is. So we need to know the relationship between shoes and pair. And here we know that 1 pair, hopefully, is equal to 2 shoes. So I'm going to take my given piece of information. So I'm going to take the 25 pair, put it over 1. And then I'm going to go ahead and set this up so my conversion factor of pairs on the bottom, shoes on the top, and fill in my value. So 2 shoes is the same as 1 pair. And so when I multiply straight across, I get something like 50 over 1, and I can't make that any smaller. So my final answer here is going to be 50. And I see that units of pairs cancel out, and it's going to be left with shoes. Okay. So that's our first example where things are comfortable. So these examples are pretty comfortable because we're used to dozens and we're used to shoot and we're used to like pairs and things like that. The next example that we're going to go through is a little bit less comfortable. In order to do that, I'm going to give you a present, and the present looks like this. So I'm going to give you a present and hang on. All right. So as I discussed, what we have here is we have a bunch of relationships on the bottom or on the back side, and on the front side we have our friend the periodic table. Okay. Now we'll use the periodic table a lot, but for now, this unit you're going to be using this piece of paper often, especially for today's class and tomorrow's class. So moving on to something that is less comfortable, we now have the relationship where we're going to be going from metric to metric. So we're going to be converting metric to metric. And I know that the relationship that I'm looking at here is meters and kilometers. And what I want to point out is that in the word kilometer, there is the word meters. And that's kind of important in terms of why we can cancel some things out. So I'm going to set up my conversion factor. So I'm going to have meters, and I'm going to try to remember what makes kilometers and meters the same. And this is one of the few relationships that you have to memorize, okay? And so in this case, hopefully you will remember that 1,000 meters is equal to 1 kilometer, okay? And then the next thing I'm going to do is I'm going to simply take the 1,250 meters, put it over 1, and then I'm going to set up my relationship so that meters cancels out. So I'm going to put the unit of meters on the bottom and the unit of kilometers on the top. And then I'm just going to fill in my values. And since I have already identified that 1 kilometer is equal to 1,000 meters, I'm now going to go ahead and multiply straight across. So what I see is that I get 1,250 over 1,000. And so when I simplify that, I get 1.250. And when I want to try to assess what my unit is going to be, meters cancel out because they're on the top and the bottom, and my answer is going to have kilometers as a unit. So hopefully that wasn't too terrible. So now we're going to go ahead and give another one a try. And that one is going to be inches to centimeters. So this is going to be a scenario where we're going to go from English to metric. And so we're looking at inches and we're looking at centimeters. So I need to find the relationship between inches and centimeters. And I don't know about you, but I just don't go around memorizing random facts. So I'm going to go and look at my conversion factor sheet that I have just received because it's my new best friend. Okay. You should probably name your periodic table. This one is my periodic table, and I've named it Jethro this year. So yeah, so like when I say I'm going to get Jethro out, like this, I'm talking about my periodic table. You can name yours Stan or Sally or Teddy Ruxpin. Anyway, so in this case here, because we're going from English to metric, which is right here on the top, I'm looking for a length because I know that inches is a length measurement, and I'm looking for the relationship between inches and centimeters. And I find the length measurement, which is right here, and I find in the top row that it is 1 inch is equal to 2.540 centimeters. So I'm going to record that in my graphic organizer that 1 inch is equal to 2.540 centimeters. And now I'm just going to do the math problem just like we've been doing the other ones. So I'm going to take 65 inches, put it over 1, and I'm going to put inches on the bottom, and I'm going to put centimeters on the top, and I'm now going to fill in the value, so it's 2.540 centimeters is equal to 1 inch. So now I'm going to simplify, multiply straight across, and when I do that, I get 65 times 2.540, which gives me a value of 165.1 over 1, because 1 times 1. And I can't really simplify that anymore, so I'm going to go and get a value or record my numeric answer to be 165.1. I'm going to recall from the problem that the unit of inches cancels out, and when the unit of inches cancels out, that tells me that my unit is going to actually be centimeters. So there's my final answer. So now what I would like you to do is I would like you to give the next one a try. I believe you can do it. It's a little challenging, but I have faith that you can do it. So I'm going to give you a little bit of time here to go ahead and practice this one and give this one a shot. And then we'll check in. All right, so what I saw is a lot of you are like connecting the dots on this one, and I totally get that this is a little bit confusing. So here's what I did, okay? I took 6.25 times 1 times 10 to the 9th nanometers over 1 meter, and I got 6.25 times 10 to the 10, which gives me 6.25 times 10 to the 10 nanometers. But what I heard some people saying was things like, I just don't know what to do with it. So like, if it really makes you feel better, you could have done this. Right? Which would basically be here. Like that, right? Because that's what 1 times 10 to the 9 means. Right? That's kind of what we talked about with scientific notation yesterday. So you could have done that, or you could have put in your calculator as 1 times 10 to the 9. And so one of the things that I'm going to do in class tomorrow is give you a brief calculator tutorial about how to do that, okay? But for now, I just wanted to kind of jog your memory or have you think about what that number means. So if I took 62.5 times, what is that, 1 trillion-ish? 1 billion? Yeah, you're right. Yeah, million, billion. All right, yeah, because math is hard. Okay, so if I took 62.5 times 1 billion, I would get 625 with like 8 zeros after it, which is what this means. right? Because that is what that means. Okay. So I purposefully gave you an opportunity to try that one on your own because I wanted you to kind of see that and be like, what do I do with this? Well, now you have a little bit of a what you do with this. So there's one more in our note packet. There's one more practice problem. I would like you to try that one. It looks like this. I would like you to try that one now. So like I said, I got to check in with a lot of you, and it looks like most of you are on the right track. So in this case here, we found the relationship between feet and mile, because it's English to English, to be 5,280 feet is equal to 1 mile. So then I set it up where feet cancels out. I have feet on top, feet on the bottom. I have miles on top. And then I multiplied across the top and multiplied across the bottom, and I simplified, and I got 3.03 miles, right? And then my feet units canceled out, and then that's that.
Did you say you have to always put in 0 after whatever number you get?
Not necessarily. We're next week I'm gonna be really, really, really strict about how you report your answers.
Yeah.
Right now, I just want you to get this process down. Okay. So that being said, nice job today. Because you all did so great, I'm not going to assign homework tonight.
Favorite teacher.
Debatable at best. But
Just literally got to
okay, so
Do you want this back?
See,